Alright, so hi guys. So I do want to apologize for the lack of uploads. I have been so busy, with just a lot of things, just personal life, etc. And, I have not been able to upload or make a video. But in this video, what we're going to do is we are going to go ahead and do this problem. Now, the reason why I'm doing this problem is because I myself got a little bit stumped with this calculus problem. Now, it says evaluate the indefinite integral by completing the squaring using U-substitution. I went ahead and gave the method in which we're going to go ahead and integrate this. So let me just write this down. So it says the integral of x plus 3 over, and it's x squared plus 6x plus 7. Now, obviously, we cannot factor the denominator here. So the best thing to do in this case is to actually complete the square for this. So we're going to go ahead and complete the square. And I'm sorry for my handwriting, guys. So we're going to go ahead and do that. Now when I do that, I have x squared plus 6x plus 7, and I'm going to make this equal to 0. Now, the way that I'm going to do this, we always go ahead and subtract 7 on both sides. If y'all don't know how to do this, I do have videos on my channel over how to complete the square, if y'all are interested. And so then what I'm going to do is I'm going to add some random number. Let's, I'm going to put in a kind of a filler here. I'm going to say C1, and C1 is any kind of number, right? Now we are going to use a formula to find that third term. Now when I add the C1 to the left, I do it to the right as well. So we have negative 7 plus C1. So I always like to do it this way because, like, this is not one way that they're not going to usually teach it to you like this in textbooks. But this helped me a lot when I put in, because for me a space was too confusing. So I always put a C1 like that. Okay, so I want to go ahead and define my variables here, or my terms. Remember that I have ax squared plus, and it was, let's see, bx plus, and then c, right? Now, the only thing I do have here is, and I'm going to actually say C1 in this case, because that's the third term there. Now I'm going to go ahead and define my a, b, and c. So I have 1x squared plus, and then it was 6x, and then plus my C1 term. And it was gonna, and this is gonna equal, and actually let me write it down a little bit better. It's gonna equal negative 7 plus C1, because again, we're just adding it to both sides. And then from here, we know that, so a equals 1, b equals 6, and in here, we know we're trying to find the C1 term. So the way that the formula goes for the third term, guys, C1 is always the middle term, so b, and then over 2, and then all squared. So I know that for my third term, I'm going to put C1 is equal to, and it's going to be 6 over 2 quantity squared, which is equal to 3 squared, which equals 9. Now, this is, so I know that that is what will go in for this, okay? So therefore I have x squared plus 6x plus 9 is equal to, and it's going to be negative 7 plus 9. Okay. Now, from here, we're going to go ahead and just simplify this. If you think about it, guys, this part here is really going to be, the way that this goes is going to be x plus b over 2, and then all squared like this. Okay. Yes. And so I know again that my b term was 6. So I'm just going to go ahead and put this in here. And I know that this is equal to 2 because negative 7 plus 9 is 2. So then we have x, and it's going to go, hold on, it's going to be plus 6 over 2, right? Squared is equal to 2. Now, here we're going to have x plus 3 quantity squared is equal to 2. And what I'm going to do is I'm going to subtract this 2 on both sides, giving me x plus 3 quantity squared minus 2 equals 0. Now, this expression, guys, and it's without the 0, or without the equals 0, but that expression is really what x squared plus 6x plus 7 is. So we can state that x squared plus 6x plus 7 is equal to the quantity x plus 3 squared minus 2. And so here we have, let me see, it's going to go, so we're going to put this in for the bottom. So therefore the integral, thus, the integral of x plus 3 over x squared plus 6x plus 7 is dx is equal to the integral of x plus 3 over the quantity x plus 3 quantity squared minus 2 dx. So now we have it in this form, guys. So that is like the algebra part of this. And yes, this is a lengthy problem. I do apologize. But now what we're going to do, we're going to go ahead and do the following. So let's see. I know that in this case, I can make u equal to x plus 3, right? So I can use U-substitution to actually integrate this part. And so from here we have let u equal I'm trying to think here. It's gonna go, hold on, guys. I'm sorry. Give me a second, everybody. Hold on. Okay, guys. So I'm gonna let u equal to x plus 3, and then du will equal dx. Okay. So from here, I'm gonna say the following. So again, the u is this, and the du will be this. So it's gonna, I'm just really being specific in stating that. So we're gonna have the integral of u, and then over, and it's gonna be u squared minus 2. Okay. Now, the thing with this one, guys, is that you need to do u substitution twice. I mean, obviously here we still, I mean, we can't really do anything with this yet. Obviously, I mean, yes, we have u over u squared minus 2 du, but I'm gonna use, and in this case use substitution again. In this case, V substitution. Okay. So we're just gonna go ahead and do that. Give me a second, guys. Now, for this, we're gonna go ahead and say that V is equal to U squared minus 2, right? And then dV, so I'm gonna write it this way, guys. Hold on. Actually, yeah, and then dV will be 2U and then du. Now in this case, we're gonna go ahead and substitute. So I'm also gonna solve for du. So let me write it this way. Give me a second, guys. Okay, guys, so I'm gonna try to explain this here. It's a lot of colors that I'm using. So okay. V is gonna be U squared minus 2. So I know that this portion right here is gonna be my V, what V is, right? So this will be V, and then when I solve for du here, I'm gonna solve for du algebraically, so I'm gonna do over 2u on each side. So I'm gonna do divide by 2u, and so if you'll hear an airplane in the background, I apologize. So it's gonna be dv over 2u, and there's a reason why I'm color coding so much, is equal to du. Now, here, we're just going to substitute, so this is going to equal to the integral of u over v, because we made the denominator equal to v, over v, and then the du in terms of the du in this part, not in the previous part, but in this part, we made it dv over 2u. So we're just trying to get everything in terms of v, guys. We are not gonna, once we get the final integral, we are gonna substitute everything back in. So you want to be careful. I know this is a lot, and I apologize. This is really difficult. And it's going to be over 2u. Okay, so it's going to look like this. Now, we know that we have everything in terms of v at this point, because the u will cancel out, so this is going to equal the integral of dv over 2v. So it's going to really be like this. I really should have used highlighters, guys. I apologize. So, in this case, we're just going to go ahead and integrate this. This is really the integral of 1 over 2v dv, which is 1/2 integral of 1 over v dv. We know that the integral of 1 over v dv is really the natural log of absolute value of v. So we can say that this is equal to 1/2 times, and we know that for this part, I'll use this highlighter. This part, we're going to put in this. So we're going to put natural log of absolute value of v. And then finally, we're just going to go ahead and state it the following way. So I know now that I'm going to substitute back v in terms of u. So I know v, let me actually highlight it this time. V in terms of u was v is equal to u squared minus 2. So I know that that's what v was. So this is equal to 1/2 natural log of absolute value of u squared minus 2. And now we're just going to put, and I'm going to go ahead and rewrite this. So again, 1/2 natural log of absolute value of u squared minus 2. The reason why I'm rewriting it again, guys, is because we're going to put in u, we're going to put u back in. U was x plus 3, so we're going to have u is x plus 3, so I want to remind you guys, u is x plus 3, and then finally, we're just going to put, that this is equal to 1/2 natural log of the absolute value of x plus 3 squared minus 2 plus my constant of integration c. And so finally we can conclude that therefore the integral of x plus 3 over, and it was, I'm sorry guys, it was over x squared plus 6x plus 7, right? Over x squared dx is equal to 1/2 natural log of absolute value of x plus 3, of x squared minus 2 plus my constant of integration c. Or I'm going to also say this, if you want, you can expand this too, or 1/2 natural log of, and it's going to be x squared plus 6x plus 7 plus my constant of integration c. And I'll just put it this way, or the integral of x plus 3 over x squared plus 6x plus 7 dx. So these are two ways in which you can write the answer, guys. So that is how we do this problem. This is really, really lengthy, only because we have to know how to complete the square, and we have to know exactly how to just integrate using U-substitution and natural logarithms, and also integrate twice by substitution. So that is going to be it for this video, guys. I hope that helped, and I hope this didn't take so long either. But with that being said, thank you so much for watching, and if y'all have any questions, please let me know, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.